Okay, guys, welcome back again to another moment of transitioning beyond knowledge to gain understanding. So, for today's class, we're going to be continuing on where we stopped on indices. We started this journey on Monday. We talked about the concept of indices, and the day before yesterday, which was Wednesday, we looked into different examples about indices. And for today's lesson, we're going to continue by observing or examining indices involving equation. Now, this is my day 3 of showing up on on YouTube Live to discuss about math related concepts. Now, the joy here is for me, I try to break things down. That's what I love. I try to pass what I have accumulated over the years to make math simpler and entertaining, and help you understand math in a very, very simple way so that you'll be able to relate. Because for me, every complex thing that you see or you have seen in math before involve just simple steps just built up together. That is what has amounted to the complex stuff that you see. So that is what I'm here to do, to try to make you carry you along in the journey of math. So stick with me on this journey. So for this particular class, we're going to be discussing indices involving equation. We already have about 6 laws that govern indices, and these laws, all of these laws, has to do with base and power, because the concept of indices thrives on two basic things: the concept of base and also the concept of power. And it goes in this form: if I have x raised to the power of n, this x here is what is known as the base, and the n here is known as the power. So what indices seeks to do is to reduce the expression on numbers in general into a base and a power. So I can go ahead and go as far as reducing something like, let's say, 64, which you know that is just a normal value. It just tells us, oh, you see, I can represent this 64 so that it will be a base raised to a power, which simply means a particular number multiplying itself successive time to give us this 64. So that's what indices tells us. And it turns out that there's a way I can represent this 64 into reducing it to be a base of 2, then raised to the power of 6. These 2 raised to the power of 6 and 64 mean the same thing. So, but indices brings that power aspect to life, where you have a power and a base. So that is the basic concept, or the basic idea, that indices seeks to take us on a journey around, and that is what I'm here to do. So thank you so much for joining, guys. So we'll go on to talk about the indices involving equations. And like I said, when you talk about equation, the simple way that I try to visualize equation is, for you to talk about equation, you're trying to equal two things or two or more things. So the concept of equation comes from equality, and it is actually what makes equations really, it makes it something, is the concept of the equality sign. So if I want to say that this thing is equal to this, I use the equality sign. And the equality sign there is just a comparison sign, trying to compare two things that are positioned on the two sides of the equality sign. So when we talk about the equation or indices involving the equation, what you are simply trying to do is to simplify mathematical variables or numbers in such a way that what is on the left hand side portrays what is on the right hand side, just like we do under normal equation, which is your linear equation, your normal equation. That's what we do. So I'm going to continue by bringing in some examples for us to examine under this particular concept, and we'll starting with the basic one, which is this. Let's use this example as a basis to get into this expression. If I have 5, this example under this is equations or indices involving equation. If I have 5 raised to the power of 2x minus 4, then minus 1 equal to 0. Now, this is an equation. Why is it an equation? It's an equation because there is an equality sign. And not just that, because the key thing that makes equation what it is actually the variable, the unknown variable that you see, okay, in the expression given. So this is an equation, first, because of the equality sign, secondly, and most importantly, because of the unknown variable that we are asked. So if the question is, if 5 to the power of 2x minus 4 minus 1 equal to 0, find x. Okay, so I know that this is usually, people tend to talk about this a lot. Why is it always x? Well, it's kind of a thing in maths. We're just used to x and y. So bringing in another variable is not really something huge. We can do that, but it's just like we have stuck up with using x and y. So if we go on to solve this given expression, 5 raised to the power of 2x minus 4 minus 1 equals to 0. Meaning that what this expression is trying to tell us is that everything on the left hand side, which is 5 raised to the power of 2x minus 4, then minus 1, is equals to what is on the right hand side, which is equals to 0. So the process of making that to be true is what we mean by solving this equation, and us proving that this particular word expression is correct. And the only thing that will prove that is this value of the unknown variable, because there has to be an unknown variable that you impute here, so that if you solve this left hand side, it will be equal to 0. That is what you're here to do. So what is the process of going about solving this? It's indices. Well, if I look at this expression, since there is an equality sign and there's a 1 here, I'm thinking of something. I don't know if you're thinking of that as well. I could move this -1 over to the right hand side. Well, if I did that, it's not really much, but it can get us started into solving this equation. So this is going to be 5 raised to the power of 2x minus 4, which is now alone on this left hand side, equal to 1. Well, you could say plus 0, but we know that it's still going to be equals to 1, because 0 added to anything will still give you back that thing. So what we're going to have here now is that we've kind of not done much, but we've done something, and that can get us started. So if I go forward, I can write it as 5 raised to the power of 2x minus 4 equal to now 1. Because 1 plus 0 on the right hand side is just going to give us 1. Well, the next thing to do is this. Since indices is interested, because indices comes from the word index, like I said at the beginning of this class. Indices is interested with index, and index in maths is something as powers. So, if indices is truly about powers, and for there to be powers, there has to be a base. Is there a way I can turn this 5 into having a base and a power? Because that's the whole idea of indices. Well, there is, because I know that under the basic law of indices, any variable or any number at all raised to the power of 0 equals to 1. So I can actually turn this 1 to become any variable at all raised to the power of 0. And what better variable to turn into than the variable that we have here, which is the base of 5. I don't need to turn it to 2 raised to the power of 0. Well, because it's not really going to help me here. It's not going to help me. So what I'm simply going to do is make sure that I turn it to be a base of 5. Having a power of 0, because that is still going to give me 1. So if I go forward to do that, oh, I didn't see your comment. Ajin, thank you for joining. Thank you for joining. I really appreciate you here. What is happening? I'm good, brother. I'm good. Thank you for joining. Thank you for joining. So let's continue, guys. So I choose to make this my 1, which I want to change here, to become 5 raised to the power of 0. So that becomes 5 raised to the power of 2x minus 4 equals to 5 raised to the power of 0. We are dealing with indices, so don't get me wrong. We're just dealing with indices. We have to do with a base and a power. So this 5 raised to the power of 0 is still equals to 1, so we've not really deviated. We are still within what we are trying to solve here. So once we arrive at this, there's a certain law of equality sign and also indices. We say that if the bases are equal, it simply means that their power must be equal. So since the bases are equal, we equate their powers so that we can find the value of these x here. So simply put, we now stop losing the base. We just go over to their power because we've examined that the bases are the same. So this now becomes, bringing down the power, that 2x minus 4 equals to the power of what's on the right hand side, which is equals to 0. And that gives us what? A linear equation which we can easily what? Dump over as easy as possible. So yes, we just move what? -4 over to the right hand side. And I want to address something that is very, very important under this approach that I want to use. Now, for most people, what they basically do at this point is add +4 to both sides. Because the whole idea of equality sign simply means that what is on the left is equal to what is on the right. So whatever you're doing for what is on the left hand side, you must equally do that for what is on the right hand side. Very, very important. You can't do for one and leave the other. So one of the ways of going forward to solve this question, which people normally use, is that they add +4 to both sides. So if we do that, this is going to be 2x minus 4, then plus 4 equals to 0 plus 4. This is what you can do. And if you do that, -4 plus 4 is going to clear out. So that what you have remaining on the left hand side is simply 2x equals to 0 plus 4 on the right hand side is going to give you what? 4. And if that is what you have remaining, all you simply need to do at this point is divide both sides by the coefficient of the unknown, which is x here. But where I want to focus on before I get to this point is what I just explained here. You see what I did? Most people tend to love using adding of 4 to both sides. If it was a positive that was here, if this was 2x plus 4 equals to 0, and we wanted to simplify further, we could say add -4 to both sides. Because we are trying to clear up the left hand side so that it is just the variable, which is the unknown x, that is remaining. So we're trying to clear it up. So this method can work. Also, we can decide that instead of doing that, a short method that I love using for this particular approach is if I have 2x minus 4 equals to 0, what I simply do is move -4 over to the right hand side. This is quite simpler for me because it helps me to visualize the change that is actually going on. Something is crossing the equality sign. And it's usual, when something crosses the equality sign, it's going to what? Become, the sign is going to change. Anytime something crosses the equality sign, the sign is bound to change. So if -4, because sign comes before any given number, if it crosses and moves over to the right hand side, it's going to become +4, which is what we arrived at if we use this original method. So I'm just teaching you two things. If you can, anyone that is okay for you, you can go about using it. Okay? Thank you so much. Wow, Iron Guy, I see your comment. That was refreshing. My insert thought process was to use logarithm, completely slip the zero exponential. Wow, brilliant, brilliant. Thank you, Iron Guy. Thank you for joining. Thank you for that, brother. So what I'm simply going to do is continue with this approach, but I already told you that if this was an exam, I don't bother going through this way. I just move the -4 over to the right hand side. So let's finish up with this particular approach that I have here. So here, what I simply did was adding +4 to both sides, and what I have remaining is just 2x equals to 0 plus 4 on the right is going to give us 4. And then we'll go about dividing both sides by the coefficient of what? The unknown. Remember, dividing both sides. Why are we dividing both sides? Because there's an equality sign here. Dividing both sides by the coefficient of x. So that's why I'm going to do here. Why we are dividing both sides is because I'm reiterating what is on the left hand side. Because of the equality sign here, what you do for the left hand side, you equally do for the right hand side. So this is going to be 2x equals to 4. Divide here by 2, because 2 is the coefficient of the x here, and also divide here by your 2, so that your x here is equals to what? 2. 4 divided by 2 is going to give you 2. So the variable x that will make this given expression, remember this is the original expression that was given, the variable that will make it to be equals to 0 is what? 2. And let's go ahead and check that, because this is not just us trying to, bring in something and not make sure that we verify the information. If we substitute x here to now be equals to 2, what is it going to give us? So this now becomes 5, substitute 2, and then your x here becomes 2, because we found our variable x here to be 2. Then minus 4 minus 1. Is it equals to 0? We are just trying to find out. So if we use this now, it's going to give us 5 raised to the power of 4. 2 times 2 is 4, minus 4, then minus 1. Is it equals to 0? Well, I think you're already getting the gist now. I think we are approaching 0 at this point. So that what we have remaining here, I'm going to clean up here. What we have remaining here is going to be that 4 minus 4 is going to give us 0. So what we have here is 5 now having just a power of 0, because we have subtracted 4 from 4. And then minus 1. Is it still equals to 0? Still checking. Anything raised to the power of 0 equals to 1. So this entire expression here changes to 1 according to the law of indices. And then you now have 1 minus 1. Is it equals to 0? Yes, because 0 is equals to 0. So the answer that we got for this expression while solving it, which is that our x is equals to 2, satisfies this given expression. So remember, the whole point of an equation is, first, there must be an equality sign. There is no equation without an equality sign. And secondly, there must be a variable that you're looking for. Just like in real life, because this is very, very applicable in real life, in business model and all that. Because there is always something you are looking for. And there is always something that is available to you. Let's say you have this, you have that, you want to get the other thing. The other thing you want to get becomes a variable. That's what you're pursuing and all that. I hope this made sense to you all. So this is it. This expression is how you solve indices involving equation. And the reason why it's equation is because there is an equality sign first, and secondly, there is a variable that you are looking for. So take note of that. I'm going to clean this now. I'm going to give like 2 seconds for you to, if you want to take a screenshot, take a screenshot. Thank you so much for joining, guys. I really appreciate you for being here with me. Thank you. So I'm going to give just 2 seconds. 1 and 2. Let's solve another problem. I took long time to solve this because I was trying to do some basic explanation, because I like breaking things down. Yes, I don't just like solving like out of the blue. I try to understand concept very, very well, and why some things are the way they are, not just blindly solving. I love exploring the why. So that is what I bring to you on this space. So another question for us to consider that looks much like this is the second one. If we have 8, if x raised to the power of 2x minus 1, I think, is equals to 1 over 512, find x. Yes, find x. So we're still considering indices involving equation, and the first question I will consider has to do with linear equation in the end. This is also a linear equation, but indices involving equation can go as high as giving you, producing a simultaneous equation which has to do with the 2 equations being solved at the same time, or a quadratic equation. So it depends, it can go high and high. So we're just considering the linear aspect of this. So to go forward to solve this now, what do we do? Well, it's always good to start with the basics. What can you do basically in the most basic form? Well, since we are discussing about indices, and indices, like I said, has to do with index, and index in turn has to do with pairs. It simply means that we need to find a way to express, this is already a base having a power, but this, we need to do something about this 1 over 512. We need to do something slightly about it. And what are we going to do? Well, I could do 8 raised to the power of 2x minus 1, bringing up what is on the left hand side, equal to, I know from the law of indices that anytime you have maybe a variable raised to the power of negative, it means the inverse of that variable raised to the power of the positive of that a. So what am I thinking here? I could switch up this 1 over 512 to be 512 raised to the power of negative 1. Yeah, because it's inverse. So this is the first step. Well, it's not really much, but it can get me started into solving this given expression. So when I do that, the next thing to reason out here is we already have 8 as a base here. What can we do to this 512? Is there a way we can reduce it? Because 8 on the left hand side has already given me a clue. Give me a clue that to ask the question, because it's not mathematics is about curiosity, and that's what also science brings. It's about curiosity. Since I have that 8 is a base on the left hand side, a natural question should be, is there a way I can reduce this 512? Since index is about reducing a large number, a complex number, into a base raised to a power. So is there a way I can reduce this 512 to have a base that is 8? That means, is there a way I can make this 512 to be 8 successfully or consecutively multiplying itself? Well, there is. It turns out that 8 multiplied to 8 multiplied to 8, which is same thing as 8 raised to the power of 3, gives me 512. Aha! So this gave me a clue on what to do here. So I can first of all go now equals to this 512, we switch out to become 8 raised to the power of 3. So what I'm going to have here is 8 raised to the power of 3. Then there is still an external power of negative 1. So I'm going to bring that into play here as well. So if you close up this bracket and you have your negative 1. Yay! I think we have a clue now on how to progress from here. So what do? Nothing much here, but according to the rule of indices, I can still go on to apply the basic law, one of the laws of indices, which say that if I have a base raised to a power, and then there's a bracket and there's an external power, what I simply do is I'll just open up the bracket and multiply the power. Alrighty. So sorry guys for that glitch. I had a momentary glitch, but we are back now to continue from where we stopped. Thank you. So to proceed with this, what am I going to do? Well, it's quite simple. At this point, what I'm simply going to do is look at the left and the right hand side of this given expression. We see something very, very common, that they have the same base. And one of the rules of indices is, if the bases are the same, it simply means that their powers are still the same, because that's one of the reasons why we had to reduce this 512 into a base in between what is on the left hand side. So since now we have a base and a power for each of the sides, we can now compare the bases. Since the bases are the same, it simply means that their powers is the same. So taking note of that, we'll now start examining the power and need the base. So bring out 2x minus 1 equals to negative 3. By the way, there's a name for this. You can simply come here and say, since the bases are the same, then the powers must be the same as well. So yeah, so that's what we just applied here. And so if that is the case, this is now what we have. The power of what is on the left hand side equals to the power of what is on the right hand side. So at this point now, what do you think we're going to do? We are now looking for the variable x. So we can apply the previous method that we said, which is what is beside the variable here is negative 1. So we can just say add positive 1 to both sides. Both sides. Now, the reason why we're doing that is to clear off some of the things that are on the left hand side where the variable is, because we're looking for the variable and we're trying to clear everything that is around the variable up so that we can find it efficiently. So going forward, this is now going to give us 2x minus 1 plus 1. This plus 1 comes from the statement that we made here, which is to add positive 1 to both sides. And if you do that, it's equals to what's on the right hand side is going to be negative 3 plus 1. This goes on to cancel off this, and what you have remaining is just that your 2x is equal to negative 2 plus 1 will give us negative 3 plus 1, sorry, will give us negative 2. And then you have negative 2. And then you go on to divide both sides by the coefficient of x. And the coefficient of x is simply the number that is close or beside the x variable here. So that you have 2x divided by 2 equals to negative 2 over 2. So that if you divide this, you see that your x is equals to negative 1. So what this simply means in summary is that the value of the expression here, which will make what is on the left hand side to be equals to what is on the right hand side, is actually what? Negative 1. And we can try that to verify that. Let us verify this particular information ASAP. Let's verify it. So to verify it, I'm simply going to substitute the value of x, which I found here to be negative 1, into this given expression. So if I do that, this becomes 8. Let me call this check, because we're trying to check whether the given expression, the value that we got, satisfies the expression that we have here. So if we go about and substitute the value of our x, which we solve for here, to be negative 1, we substitute it, it becomes 8 to the power of 2 multiply negative 1 minus 1 equals to 1 over 5, 1, 2. And if I go further to solve, this 2 is going to multiply the negative 1, and that's going to give us 8 to the power of negative 1, then there's also a negative 1, negative 2, sorry, negative 2, negative 1, equals to 1 over 5, 1, 2. So if we solve further, it's going to give us 8 to the power of negative 3 equals to 1 over 5, 1, 2. And we know the power rule in indices. If I have a variable, let's say x raised to the power of negative a, it is still the same thing as 1 over x raised to the power of the positive power of the a. So I can apply that law here. Anytime there's a negative on the power, it can be inverse 1 over the base raised to the power of the positive value that I have for the power. So this is the same thing as 1 over 8 raised to the power of 3. Is it equals to 1 over 5, 1, 2? We're checking. So if you solve for 8 raised to the power of 3, simply means 8 multiply another 8. That is 8 multiply itself 3 times. It's going to give you 5, 1, 2. So this is something as 1 over 5, 1, 2 equals to 1 over 5, 1, 2. So that means that the given value for the unknown variable that we found for this given expression, which is negative 1, satisfies completely this statement. This x here becoming negative 1 is the only value that will actually satisfy this given expression, so that whatever is on the left hand side equals to what is on the right hand side, which is also what we are proving to be true at this point. So yes, thank you so much, guys. Thank you. So I'm gonna give like 2 seconds for you guys to actually finish up on this. I'm gonna give like 2 seconds for you to maybe take a screenshot if you want. 2 seconds. Hope that's enough for you to take a screenshot. And then I have one more question for us to solve before we call it a day. Remember, we're still talking about indices involving equation, and for today's class we are limiting it to just considering indices that lead to linear equation. So I'm going to clean up now and solve one more question before we call it a day on this interesting section. I hope you enjoyed it up to this point. So let's solve one more question to marry everything that we said together. I'm going to solve a bit of a complex question here. Yeah, let me solve this complex question. If 10 to the power of x multiplied to 5 to the power, open bracket, 2x minus 2, multiplied to 4 to the power, open bracket, x minus 1 equals to 1. Everything here equals to 1. Then find the value of x. Find the value of x. Like I said, this is an equation that has indices, a touch of indices in it. So, like we said, since indices is talking about index, and index talks about powers, and there will never be powers without a base. So this is already spelled out for us, because you're having base 10 raised to the power of x, base 5 raised to the power of 2x minus 2, base 4. So it's already arranged in that particular format. So what do we do here? Well, what can we do We can start by doing something to this 10. They say, well, we can reduce 10. Well, I know also that 2 times 5 will give us 10. So I can reduce this 10 to be 2 times 5 raised to the power of x multiplied to 5 raised to the power of 2x minus 2, then multiply to this 4 can be reduced to be 2 squared, then open a bracket and put your original power, which is x minus 1. This is what we have here at this. So if I go ahead to simplify, I can use this power that is outside here and share to each of the expression here, because what I'm trying to achieve here is this. Since there's no connection between 5 and 4 in terms of base, I'm trying to find a way to reduce the given expression so that if there are bases that I can combine together based on the basic laws of indices, I'll do just that. So this will go on the x, which is the power for the 10, and now I've reduced the 10 to be 2 multiply 5. Everything raised to the power of x. So I'm sharing the power of x to what is inside. So this is going to be 2 raised to the power of x multiplied to 5 raised to the power of x. Now multiply to 5 raised to the power of 2x minus 2 multiplied to 2 raised to the power of 2, multiply everything inside here, becomes 2x minus 2 equals to 1. Now I can simply rearrange. How do I rearrange? I can take this and this and affect the 2, and I can also take these 2 and affect the 2 of them. So how do I do that? Simple. I'll bring them together. So this is 2 raised to the power of x multiplied to 2 raised to the power of 2x minus 2 multiplied to 5 raised to the power of x multiplied to 5 raised to the power of 2x minus 2 equal to 1. So this is what I have at this point. So what's the next step? Multiplication of indices, provided that the bases are the same, simply mean addition of the power. So I pick one of the base and then add the powers. It becomes x plus 2x minus 2. Same thing for this 5. It becomes pick one of the 5 because the bases are the same. Pick one of the 5, then add up the power. X plus 2x minus 2 equals to 1. So at this point, we can simply add up what we have here. X can add up to 2x to give us 3x. So this is same thing as 2 raised to the power of 3x minus 2 multiplied to 5 raised to the power of 3x minus 2 equals to 1. Well, that we haven't arrived at the value of the variable that we're looking for, which is our x. But this is good progress. This is good progress. We're making significant progress. So what can we do next at this point? Thinking out loud. Well, I can do something about this negative sign here. I can reverse. I can reverse engineer this particular statement here to be. I can reverse it to become 2. Just making sure that. Let me reverse engineer it to become 2 raised to the power of 3x divided by 2 raised to the power of 2. What did I do here? I just reversed what we have here. Because subtraction in it simply means division if you reverse it. So this is the same thing as what we have here. Just that in this form, we have expanded it or simplified it to become this. So this is what I want to do at this point. So if I do this, this is just for this part. I'll do the same thing for this 5. So I can put a bracket here to separate what I'm actually doing. So if I do that, this becomes times, I can do this for 5, becomes 5 raised to the power of 3x divided by 5 raised to the power of 2. Same process. Everything here equals to 1. So once I get to this point, what am I going to do? I'm going to change this division. The traditional way of writing division is 2 raised to the power of 3x. It can be now divided by 2 raised to the power of 2. Then multiply to, same thing here, 5 raised to the power of 3x. Change the division to be over 5 raised to the power of 2 equals to 1. I'm getting somewhere. Just stay with me. So at this point, what do I do? Well, I can just pull everything together. This becomes 2 raised to the power of 3x multiplied to 5 raised to the power of 3x all over. This can multiply out. So this is the same thing as saying, yeah, I can just leave it this way. Multiply 5 raised to the power of 2 equals to 1. And since I'm looking for x, so what do I go on to do at this point? I can cross and multiply here. And by crossing and multiply, everything here will go and multiply what is on the right hand side. So I'm going to clean up here to continue from where I stopped. So this now gives us 2 raised to the power of 3x multiplied to 5 raised to the power of 3x equals to what you now have on this side, which is 2 raised to the power of 2 multiplied to 5 raised to the power of what? 3, 5 raised to the power of 2. So if we get to this point, 1 minute. So what I'm going to do at this point is quite tricky, but tell me what you think about it once I'm done. If we have this kind of expression, see what I'm going to do. Since their powers are the same, what I'm going to do is put both of them in the same bracket and then put a power of x on top, because if I expand it back, it's still going to give me this. And I'll just multiply this out. This is same thing as 2 squared is 4, and this 5 squared is what? 25. And if I do that, what am I trying to achieve? I try to put a common base for the both of them. So this is now going to give me 10 raised to the power of 3x equals to 100. So if I get to this point now, I can now simply reduce this 100 to be 10 raised to the power of 3x equals to 10 raised to the power of 2. And according to the laws of indices and the involved equation, once the bases are the same, the powers are the same. Simply put, we consider the power. Now, the power of what is on the left is 3x, and what's on the right is 2. And so to find our x, we just simply divide both sides by the coefficient of x, so that our x is now equals to what? 2 over 3. Meaning that the value of the variable power here that will satisfy this expression, what's on the left-hand side, to be equals to 1 is equals to 2 over 3. So what I want you to do is take this value of your x, substitute it where you have x here, and reduce it. And see that if you solve what is on the left-hand side here, is it going to give you 1? Do this, and when I come live again on Monday, because next time I'm going to be coming live is on Monday by 4 p.m. So take note of this time. By Monday by 4 p.m., I'm going to come on live, and this is the question that we're going to start with to look at the assignment that I gave you. Thank you so much, guys, for joining. Thank you. Before I go, I want to ask a question. Thank you. For those that are joining us, please, where are you joining from? This is Uncle Sam. Where are you joining from? Can you please tell me where you're joining from in the chat? Thank you. Thank you for being here. I really appreciate you. Can you please tell me where you're joining from? My name is Samson. I'm joining from Nigeria, which is in West Africa, western part of Africa. Where are you joining from? Are you there? Where are you joining from? Well, thank you so much for joining. We've come to the end of our live section for today. Thank you. I really appreciate you. Thank you for staying with me up to this point. God bless you. I'll be live again by Monday, 4 p.m. Remember, the goal is to transition you beyond knowledge to gain understanding. And the way that we have gone through this section is quite impacting and impactful, yes, because I went through the process telling you the core things that you need to know. Thank you so much for joining, and see you on Monday. Bye-bye.